So now we have our collision layer and we have our joint configuration. So cool, let's do a simulation of this. The first thing I'm going to do now is I'm going to drop down a crowd source. And actually I'm going to do another thing too. I'm going to change this mockup by 3 that is just a T-pose, and I'm going to change that into a zombie. So I'm going to use this zombie walk instead. Cool. And to update that, I'm going to go into the agent. I'm going to call this walk now. And I'm going to do a reload. Okay, right. Let's go to this crowd source. So now we have all these guys here. I'm going to put this to hide. I want a bigger area, so I'm going to put this area to 15. I also want the animation to be offset, so I'm going to randomize clip times and put it to 5 maybe. So here they are offsetted. Cool. So let's drop down a DOP network. And actually before, we can't forget the agent constraint network. So in this way, it will pick up all the configuration we have done here and create constraints from this. Let's put that into the first port here, and then I'm actually gonna drop down a null here in between. I'm gonna call this constraints. And I'm gonna put that into the second port here. Alright, let's create the simulation. So first we need a crowd solver, because I want them to walk and then I want them to be triggered into ragdoll. But now we're gonna need two things, because we have the crowd solvers when we're using the clips, but then we want to use the bullet solver. So we have two solvers that we need to combine here. If I drop down the bullet solver here too, and as I hope you remember, you can do this very thing with a multi-solver. And I'm gonna connect the crowd solver first and then the bullet solver. I'm gonna drop down the crowd objects. Here's where the crowd is living, and usually I put it in the first port of the crowd solver, but now I want both the crowd solver and the bullet solver to be able to use it, so I need to put it here in the multi-solver. So in there, and then I need a crowd source. I have the crowd source here. I'm going to put that as usual in the second port here, and here in geometry source I'm going to use the first context geometry. So the first context geometry is of course this one that comes out here, and then let's go down here, and now all of them are broken. It's just because we don't have a state yet. So that's the next thing. Let's do a state here, a crowd state, and I'm going to start with a ragdoll. I'm going to make this active here, and I'm also going to go out here at the initial state. I'm going to type ragdoll. So here are our guys. Play this, nothing will happen. They will just stand there, frozen. And the reason for that is that we need a couple of things. First, we're going to need gravity. They haven't any constraints yet. They're just going to fall apart if we're going to put gravity here. We need something to collide on. So let's start with the ground plane. And we're going to merge this in here. So merge, and to the left, because left inputs affects the right input. And we need the gravity. And then, of course, we need the constraint network. So let's drop down a constraint network. And this time we have two potential constraints. Before we only had a hard constraint that we called pin, but this time we also have the cone twist constraint. Or actually, as we are using the preset, we won't have a hard constraint, but I'll put it there just in case. So I'm going to do a merge here, and I'm going to have a hard constraint. I'm going to put it in here, and like before, I need to put this into pin, and I'm going to set the rest length to 0. And the next thing I need to do is to have the cone twist constraint. So that goes in here, and let's see what is the name of the cone twist. If we go in here, we can see our name. So we can see the constraint name is cone twist. And like before, if I would uncheck one of these guys, because now all of them are cone twist constraints, but because we have this pin shapes with no rotation limits, so that means as soon as I don't have a cone twist constraint anywhere, like if I take that away, that will create a pin constraint, which is a hard constraint. Let's get that back in there. So it's called cone twist. Let's go in here again and call this cone twist. And all these top values here, max up rotation and max out rotation, and max twist and softness, all of these guys are going to be multiplied by the constraints you set up before. So let's set this to 1. In this way, you're going to get whatever you set the values to in the agent configure joint node, because it will be multiplied by 1. Otherwise you will have to go back and forth, and it would be much harder to get an overview of what the actual constraint values are. So put all these guys to 1, and here all these guys are the guys that we can find on the agent constraint network. These guys, and the same things goes here. So they're gonna be multiplied with those values, so put all of these guys to 1. Cool. Alright, and the last thing we need to do, we also need to tell them where to pick up the constraint network. And in this case, it's in the second port here. So let's do second context geometry. And now you can see all these guides turns on, which show that they are actually setting. And they are a bit big now, so let's go into the guide options and put these to 0.1. And here are our agents with our constraints. So if I haven't made a mistake, they should just fall down into Ragdoll. And yes, like so. Cool. And just as a side note, you remember that we put up the transform group before, so we can use that in here if we would want to. So if I go here and if I set this to partial Ragdoll, and then set the arm again, which was that group, and then take a clip, which is a walk, you can see that we now have this left arm flapping in Ragdoll mode, even though we are playing the clip. Pretty cool if you ask me. Okay, so but I don't want this. I want to have one Ragdoll state, and I want to have one walking state. Let's turn this partial Ragdoll off, and then also create a new state. And this state will be called walk. And I'm gonna merge these two together like so, and I'm going to just select this to walk. If you've seen my first course, you know that I like to use locomotion and not in-place animation, and also set up foot planting and clip properties. I don't want to rehash that here though, so if you want to know more about that, check that course out. But I don't want them to start in Ragdoll either, so let's go into here and then select the walk instead. And I can select it here now because the state has the same name as a clip. Otherwise you need to type in the state name. So now we have a simulation of these guys, and they are ready to be triggered into Ragdolls. I just realized I forgot to do something, and that is to go to the cone twist constraint and check this disable collisions, which means that the collision shapes that are constrained together won't collide with each other.